Hi guys, welcome to 5mantra.com. This is Kalyan, the Faculty of Aptitude, and we are going to discuss about some different concept on mensuration. This different concept on mensuration, just let us go and see what it is. So guys, next we'll do one more technique on mensuration which will be useful for solving lot of problems. Okay, based on this equilateral triangle, this is one more technique. Once again remaining, this is technique, not problem. Okay, based on this, I'll provide you the exercise in my next video. Okay, so now let us see. Here, it's an equilateral triangle. Okay, this is an equilateral triangle. Okay, in this equilateral triangle, P1, P2, P3 are the perpendiculars drawn to sides. Suppose P1 is a perpendicular drawn to this side and P2 is a perpendicular drawn to this side. P3 is a perpendicular drawn to this side. Likewise, okay, these are the perpendiculars drawn to sides. Now what is our target? Then we need to find out the length of the side. Then we need to find the length of its side. That's written in the statement also. Okay, once again repeating this. When perpendiculars, okay, perpendiculars drawn to sides of an equilateral triangle from any internal point, this white dot is there, no, this is some internal point randomly drawn. Okay, so this is some internal point. From there we have drawn the perpendiculars to the sides of an equilateral triangle and we need to find out side of the triangle. This technique or this shortcut will be helpful while solving lot of cases while doing the problems. How it will be helpful, I'll show you in the exercise video. Okay, now let us analyze the technique and let us see that what the side will get. Okay, before going to that, I want to explain you this very slowly. Let us observe what it is. For example, now here we need to find the side, no? Let the side be x. Let the side be x. So this is also x. This also would be x. So I'm showing here, this is x, this is x, this is also x, because it's an equilateral triangle, all the sides are equal, right? We are considering, we have to find out the side and we are considering this as x. That's our first assumption. Now for finding the side, I am going through one procedure. Try to observe what it is. Okay, I want to find out the area of the triangle. If side is x, what is the area of the triangle? Root 3 by 4 x square. Is it an area of triangle or not? It's an area of the triangle when it's an equilateral triangle with side x. So okay, area of the triangle. Now for my convenience, I want to find out the area of a triangle in a different way. Why I am doing this all? Final, don't confuse. Our final target is to find out x. That means side of the triangle. So I want to do that in another alternative procedure also. How we will do? Just see. Okay, let me partition the diagram. Okay, let me divide this into some pieces. How we divide this? Just see. I am joining this point to this corner, this point to this corner means vertex, and this point to this vertex. What I did? From that point, I joined all the vertices with the help of line segments. Okay, now what can you observe here? We can observe here that by these yellow lines, see, I am drawing this with yellow. By these yellow lines, how many triangles are separated from the bigger triangle? Just see, how many triangles are separated? See, you can observe this or not. You have to see my showing, point outing the pen. Okay, so see here, See, this one is one triangle or not, and this one is another triangle or not, and this is third triangle. So by using this yellow colored lines, how many triangles are separated? 3 triangles or not? Suppose I'll tell you that if you find out the area of each and every triangle and adding all them, do we get the area of bigger triangle or not? I'll show you on the diagram. Here we find out the area of this triangle, and we find out the area of this triangle, and we find out the area of this triangle, and adding them all, we get the area of the bigger triangle given or not? So we do that also. Okay, partition. Before that, let us observe each and every small triangle. Let me separate this. I'll draw here. Okay, now just see. Okay, here I'm taking this first triangle like this. Is it looks like or not? Looks like this or not? I have taken out this here. Okay, now what is this? Is this x or not? This length would be x. Now what is the length of this perpendicular given? P1 or not? P1. Now what's our next target? We have to find out the area of this triangle. From the basics of mensuration of the triangles part, we have one formula that when base means one side of the triangle is given and altitude drawn to that side. Altitude means this is altitude. Altitude is height itself. So height drawn to that side is given. Then what is its area? Half into base into height or not? Half base height. In that case, we can find out is it a triangle or not? For this, what is base? X, and what is height here? P1, right? So now, if you see carefully observe all this, here this is x, means for this triangle, okay, this x is a base and this is height, and for this triangle, I'll show you here, and for this triangle, okay, this is a base and this is a height. So from after observing all the diagrams, what did you got? Here sides of bigger triangles are acting as bases. Okay, bases for the small triangles separated. Okay, and remaining P1, P2, P3 are the heights of the respective triangles. Now we are going to find out the area of each and every triangle of them, right? Okay, now here for this triangle, what is the area? This is base, this is height, means area 1 is, okay, half into base is x and P1 is height. So its area would be half x P1. In the same case, if you want to find out the area of this portion, means this triangle, see my pen, movement of the pen, do observe. Okay, this triangle would be, okay, now what is the area of this? X is a base and P2 is a height. Then what is the area of this part? Second triangle would be A2 equal to area 2. Area 2 would be how much? Half into base is x and this would be P2. So this is area of the second triangle. This is area of the first triangle. Now let us move on to third triangle. What is third triangle? This is, okay, base, and x is the base and P3 is a height. Then what would be your area? Now A3 equal to, okay, half into base is this x and height is this P3. Okay, now third area is half x P3. Okay, half x P3. So what we did, just for small repetition, just I'm giving you small repetition here. For this triangle, area is half x P1, and for this triangle, the area is half x P2, and for this triangle, this one, Okay, area is half xp3. Now we could find all the individual triangles separately. Now if you want to get the area of this bigger triangle, what we need to do? I think you people got it. How to do it? Here we need to add all these areas to get the bigger triangle area. Okay, now we do that. Okay, now area of this triangle is again given as how much? Okay, again this area of triangle, area of the bigger triangle is given as how much? Half x p1 plus half x p2 plus half x p3. Now we can take x by 2 in common from all of them or not. Here x by 2, x by 2, x by 2 can be taken common. Now let us take common them. X by 2 times of what? P1 is left inside. Next term P2 is left. In next term P3 is left. Now this is also the area of this triangle. Means this is also the area of this triangle and this is also the area of a bigger triangle, right? So here we find the area of given bigger equilateral triangle in two different methods. Okay, anyways, whether you find by this method or you find by this method, anyhow area remains same for the triangle or not. So we can equate these two or not, because this is also the area and this is also the area. Anyways, these two, in both the cases we are finding the area of the same equilateral triangle. Get it? So now what can we do further? So here we can equate these two or not. Can we equate these two or not? Let us do that. Now what we are doing here, root 3 by 4 x square is the area where x is the side of equilateral triangle, and on other hand, okay, when P1, P2, P3 are the perpendicular drawn to the sides of the triangle from internal point, that internal point may be anywhere, it may be put. Okay, so now at that time what the area we got? Okay, what the area we got here? X by 2 into P1 plus P2 plus P3. Now we have equated these two. Okay, this area is when P1, P2, P3 are the perpendiculars taken, and this when x is considered as a side. Okay, anyways, what we are going to do, we have to find out the x or not. So we have to find out the x. Can we cut here x or not? Because if you take this x to this side, x square by x would be x only. So I am cutting directly. Now this 2 can be cancelled on both sides on denominator part. So 2 1s are and 2 2s are. Right? So now what is left here? Root 3 by 2x equal to P1 plus P2 plus P3. So now x equal to how much? This 2 by 2 will be go on to do numerator part, and root 3 comes to denominator part on changing to another side. So now this would be 2 by root 3 times of P1 P plus P2 plus P3. So now what is the value of x we obtained? 2 by root 3 times of P1 plus P2 plus P3. Isn't that our answer? Is this not our answer? What we are asked to find? We need to find out we need to find out the side of the triangle or not. That's it. X is a side we took. Okay, we considered x as a side. We have taken. Now we got the value of x or not. What is that? 2 by root 3 times of P1 plus P2 plus P3. So finally, what is our conclusion? When P1, P2, P3 are three perpendiculars drawn from any internal point in the triangle to the sides, then the value or the length of the side would be 2 by root 3 times of P1 plus P2 plus P3. Got it? So like that we need to do. And for finding that, once again, just a small explanation giving for this brief part of this one is what we did. Okay, we did here, we find here area of the equilateral triangle when x is a side, that is root 3 by 4 x square, and we separated by using these yellow lines, and those are three triangles. Separately those three triangles areas were, okay, half x p1, half x p2, half x p3. Adding all them we get also, okay, this bigger triangle area. Okay, in both the cases we are finding the area of the same triangle, so root 3 by 4 x square will be equated to half x into p1 plus p2 plus p3. Thereby, on simplifying that equation, we got a value of x, which is our side. That is our analysis to find out this. But remember guys, if you want to do the problem in your examination, if you involve this much procedure, don't you take the time of more than 5 minutes? It's a waste of time, no? So to save your time, we are choosing this as your shortcut. So finally, what is our conclusion? Conclusion would be, when P1, P2, P3 are the perpendiculars drawn from any internal point, it's not a particular one, any internal point, to the sides, P1 is to this side, P2 is to this side, P3 is to this side. Like that, P1, P2, P3 are the three perpendiculars drawn from any internal point to the sides of equilateral triangle. That is must be underlined. For which triangle it is? Equilateral triangle only. For not all types of triangles it can be applicable. Got it or not? For equilateral triangle, then we can find out the side also, and value of that side would be, now I am going to finally use the result, that would be 2 by root 3 times of P1 plus P2 plus P3. While writing the examination, okay, if some question is given related to this, do we need to involve all the procedure as we did before is required? Not required, no. We don't need to involve such a big procedure. We just need to remember this value. When P1, P2, P3 are the perpendiculars from any internal point to the sides of equilateral triangle, then its side will be equal to what? 2 by root 3 into P1 plus P2 plus P3. So, hope you guys would have enjoyed this concept video, and see, be connected to us so that we can give so many lot of videos we can provide you from this, not only from mensuration but especially for CGL and CHSL. Mensuration and geometry are main videos, so we are going to provide more number of concept and exercise videos for that. More than that, we will do lives also. So don't forget to subscribe our channels to get more updates. Thank you.